I'm Kayu, and now I'm going to do the question 8 of homework 7 for probability and stochastic processes. The question 8, we have the for the person process, we have the probability P of n of T1, T2 is equal to K is equal to e to the power of minus lambda t times lambda t to the power of k divided by the factorial of k. And we have the stochastic process x of t is equal to n of 0t. So the first question, we need to find the expected value of xt. So at first, we know the sum of the probability is equal to 1. So we have sigma k from 0 to n e to the power of minus omega t times lambda t to the power of k divided by the factorial of k is equal to 1. And then we multiplied both sides by e to the power of lambda t. So for the left side, e to the power of minus lambda t times e to the power of lambda t is 1. For the left side, it is equal to e to the power of lambda t. And then we take derivative with respect to lambda on both sides. So for the left side, we have a k times t here, and for the right side, it will be t times e to the power of lambda t. And then we multiplied on both sides by lambda t. So the left side will be k times lambda t to the power of k divided by the factorial of k, and the right side will be lambda t times e to the power of lambda t. And then we multiplied on both sides by the e to the power of lambda t. So the left side will be the definition of the expected value of x of t, and the right side will be lambda t. So the expected value e of x of t is equal to lambda t. And besides, we also want to find the expected value of xt squared. So from the above calculation, we have this sigma k from 0 to n k times lambda t to the power of k divided by the factorial of k is equal to lambda t times e to the power of lambda t. And we can use the same method. We take the derivative and then we multiplied lambda t on both sides, and then we multiplied e to the power of minus lambda t on both sides. So the left side will be the definition of the expected value of x of t squared, and the right side will be lambda t times 1 plus lambda t. And also the variance x of t is equal to e of x of t squared minus the square of the expected value of x of t. So it is equal to lambda t times 1 plus lambda t minus lambda t squared, and the final result is lambda t. So the question B, we need to find the autocorrelation R of T1, T2. So we know if T2 is greater than or equal to T1, x of T1 is equal to x of T1 minus x0, and this term, and x of T2 minus x of T1 are independent. So the autocorrelation R of T1, T2, we know by the definition, it is equal to E of x of T1 times x of T2. So we can rewind x of T1 as x of T1 minus x of 0, and we can rewind x of T2 as x of T2 minus x of T1 plus x of T1. So if we let this term times this term, we will get x of T1 minus x of 0 times x of T2 minus x of T1, and then we left this term times this term. We will have x of T1 minus x of 0 times x of T1. So for the first term, we know this term and this term are independent, so we can rewrite it as the product of their expected values. So for the second term, we know x of 0 is equal to 0, so it is equal to E of x of T1 squared. So and then we calculate their expected value. For the expected value of this one, we know x of T0 we know E of x of T1 is equal to lambda T1. And x of 0 is equal to 0. So it is equal to E of x of T1. For this term, E of x of T2 it is equal to lambda T2. E of x of T1 is equal to lambda T1. So the expected value is equal to lambda T1 times lambda T2 minus lambda T1. So for this term, we know the expected value of x of t squared is equal to lambda t times 1 plus lambda t. So this term, x of T1 squared, the expected value will be lambda T1 times 1 plus lambda T1. So the final result, we add them together, the final result will be lambda times T1 plus lambda T1 T2. So if T2 is smaller, T2 is smaller than T1, we can use the same method, but this time x of T2 minus x of 0 and x of T1 minus x of T2 are independent. So we use the same method. We rewind xt2 as xt2 minus x0, and we rewind xt1 as x of T1 minus xt2 plus x of T2. So we also have the product of the expected value plus the product of x squared. So for the first term, the result will be lambda t2 times lambda t1 minus lambda t2. So for the second term, the result will be lambda t2 times 1 plus lambda t2. So the final result is lambda times t2 plus lambda t1 t2. We can see that if t1 is smaller, this term will be t1, and if t2 is smaller, this term will be t2, and lambda and this term lambda and this term lambda t1 t2 are the same. So the final the autocorrelation R of t1 t2 is equal to lambda times the minimum of t1 t2 plus lambda t1 t2.